This conference will now be recorded.
So first, let me show the architecture of the project. Just give me a minute. Yeah, this will be the architecture that we're going to solve today. So this is the integration of Kafka and sparse structure streaming. You can see that, you'll have any source systems here. It could be, first of all, let me define the problem statement. So you try to, just give me a minute. For the interruption, yeah, I'm back. So let's say you log into Amazon and you try to purchase a product, right? And when you try to purchase a product, there'll be some details that you have to give, right? So for making a transaction, such as your card details, what's the transaction amount, and when the transaction is happening, right? All such things you have to give. So we are going to deal with that data right now. So we'll have any source systems, that is whichever is going to produce the data. So for now, we are going to write a Python producer for generating the data in Kafka. So that producer is going to produce the online purchase data as message to a Kafka topic. So let's say the topic name is test topic. Now the sparse structure streaming application is going to use Kafka as the data source, and then it's going to consume all those messages, process all the data, push the process data into Kafka topic again. Kafka is again going to act as a sink. We'll try to push that data to the output topic. And then we may have any downstream systems or target systems which will try to consume the data that is coming from that particular topic, right? So that topic we call it as output topic. So let's go step by step. So I have written the code already, so let me just launch my Python. So just to avoid any errors, what I would like to do is I want to go to my Kafka folder. I'll go to data folder and I'll remove everything here. Because this is the project that I wanted to show. So here we have some folders which I would like to delete. Let me delete those. So this is the entire project structure, right? So let us go step by step. So I'm going to close all the tabs. So first I wanted to start with producer, Kafka producer.py. So this is the Python code where we have written the producer to generate the data. So you can see that this is the starting point of our code. So line number 12, right? We have this built-in variable in Python called as underscore name underscore underscore. When you run this code, it will automatically have this variable value set to underscore main underscore underscore. So this is the starting point of your code. And here you can see environment is showing us sys.rp. That is, we are going to read it as a runtime argument. Let me show you that. Click on run, edit configurations, and here you can see that I am in Kafka producer, you can see the parameters I'm giving it as dev. What is the meaning of dev here? So the environment where we're trying to run this code is nothing but development environment. So that will go to this variable called as environment. And here we have a function called as get spark session, which will try to create a spark session object for me. If you can click on it, you can see that I have another file called as spark session helper util.py. Where is this available? This is available under utils folder. So under utils, we have spark session helper util.py. Right. So here you can see that I'm trying to create my spark session object. Spark session.builder.app name. App name is nothing but whatever app name that I'm passing. So here Kafka producer demo is nothing but the app name that I'm passing. So I'm trying to set the resource manager as local. And generally, sparse traffic streaming applications, when you wanted to deal with in the real-time projects, we have to set this property called as spark.streaming.stop gracefully on shutdown. So that will actually make sure that your applications are shut down gracefully. And as we're trying to talk about the integration between Kafka and Spark structure streaming, we need to mention this. So spark.jars.packages, we have to mention this. And finally, we have to set the get or create, right? So this will return the Spark session object. And also we are going to perform some byte transformations as I have told in the previous sessions. So we are going to set this property to 2. Otherwise, it will use 200% by default. And then I'm going to set the log level to be error because the default log level in Spark is nothing but info. If you don't set this, then you're going to see the logs for everything that we do. Hence, we set the log level by using this so that we will see the logs only whenever there is an error. And finally, we are going to return that Spark session object. So this is the exception handling that we are trying to use by using try and except, right? So this will give me the Spark session object. And then we are going to mention this log4j because in the projects we are going to use log4j for logging. Let me open this. This is how it is, right? So we are going to keep all these things. So we are going to have the log levels such as warning, info, error, debug, etc. And then, so we have to keep all the details in a configuration file. So generally, we will not hardcode anything in the project. So we'll keep everything in a file. We call it as configuration file or properties file. So where is this properties file? Look at this path. So it's under application or property. This is my configuration file. Let me show that. This is my configuration file where I'm going to keep all of my details. So what is the input topic? What is output topic? Where is my bootstrap server? What is offsets? What is the processing time? What is the mode that I wanted to use? Right? All such information I'm going to keep it here. And now I have to read this configuration file. That's where I'm going to use cp.rawconfig parser. So what is cp? Just go and look at your import statements. It's nothing but config parser. So config parser is a package in Python to read the configuration files. So we are saying cp.rawconfig parser, and we're also mentioning the location where the config parser is available, where that configuration file is available. Then we are trying to read the data. We're trying to get the topic name. So when we say props.get environment, so if you remember, environment we are set it to dev, right? If I click on run edit configuration, you can see parameters are showing as dev. So props.get of dev, and the meaning of this is, so when you say props.get of environment, so it will go and get all the properties, right? It will go and get all the properties, but from this we want only one property for now, which is nothing but Kafka input topic name constant. So Kafka.input.topic. So which is nothing but this one. So this we are going to read it into the variable called as Kafka input topic. So basically, this is the topic into which we are trying to push the data into. And here again, we are trying to get the bootstrap server details. Kafka.bootstrap.server, right? So that's how we are going to read it. And then we are trying to define the Kafka producer object where we are specifying the bootstrap servers. And as I told, we are going to deal with the transactions data. So we have a list called as transaction card type list. So this contains Visa card or MasterCard. So basically, we are going to generate this data by considering any one of these cards. So that's why we have this list. Now I'm going to define this message and I'm going to set it to none. So to start with, I'm going to generate only 5 transactions right now. So that's why the range is showing us 5. And I'm trying to define this loop counter as I equal to I plus 1. And I'm capturing the current date, date time dot now will give the current date. And each transaction will have these 4 fields: transaction ID, transaction card type, transaction amount, transaction date type. So transaction ID is nothing but this loop counter, I equal to I plus 1. Transaction card type is nothing but, so you have a package in Python called as random, which will automatically pick up one of the element from this given list. So random.choice and then this list, it will automatically pick up one of the card type. Also, we have something called as random.uniform. So random is again a package in Python. .uniform will try to generate the data within this range. Lower bound is 5.5, upper bound is 555.5, and we are using round so that we can round it up to 2 places. Suppose let's say the transaction amount is 1234.5678, right? Instead of this, we'll try to round it off to 2 places. So that's why we are using round of 2. Then we are capturing the transaction date time at what time the transaction has happened by using datetime.now. And then we are going to send that message to this Kafka topic, right? So let's do one thing. Let's try to run this code and then we will see whether the data is being generated or not. So first step is I'm going to start my Zookeeper. So for Zookeeper, instead of running those from the command prompt, I'm going to run it from the ID itself. You can see that I have created this folder structure called as Kafka scripts. I'm going to start my Zookeeper. Right, I'm going to start my Zookeeper first. So just double click on it. Okay, yeah. So sorry, right click on it, say run command script. So it will automatically anyways run it on your command prompt. You don't need to open your command prompt and do it. So your Zookeeper must be running now. Zookeeper is running. I'm also going to run my Kafka server. So right click on this, say run command script. So that will also run your Kafka. So Zookeeper is running, Kafka is running. So what I'm going to do is I'm going to create a topic, right? So ideally speaking, I should be pushing the data to test topic, but I will change it for now. So I will go to my application or properties file. So here, instead of test topic, let's say sample topic is the topic name that I wanted to have, right? So let's go to the scripts again. Let's go to this input topic script. So here I'm going to slightly modify. I'll just check whether things are fine or not. So here, instead of test topic, I'll change it as sample topic. Let's try this. So this should first create a topic for me. Right click and then say command script. So the topic has been created. Now I'm going to start my consumer. So let's see the topic name. So here the topic name also I'm going to change it to sample topic. So I'm going to start my consumer. So consumer is also running, but there is no data. So right now it's not displaying anything. So I'm going to run my producer, which is nothing but Kafka producer, right? So before running this, you have to actually say run edit configurations. So in the parameters, you have to pass it as dev. What is meaning of this dev? So it will go to this configuration file. You can see that there is a section called as dev. So it's going to read all these configuration properties. So that's why we have to give that runtime argument. And then this should actually generate 5 transaction messages form. You can see range I've given it as 5. Right click on it, say run Kafka producer. So you can see that it is generating 5 messages. You can see we have transaction ID and we have transaction card type, MasterCard or Visa card. And you can also see the transaction amount, what's the transaction amount, and the transaction date time when the transaction has happened. So these should be consumed by my consumer. You can see that all these are consumed by my consumer. So with this, I can confirm that my producer part is fine. So I'm able to produce the data into a topic and I'm able to consume it for now by using Kafka console consumer. So this portion is fine. Now let's focus on this part. So now I'm going to use Kafka as my data source and I'm going to consume the data by using Spark Structure Stream. So let's go here. I'm going to stop my consumer saying Control C, type Y. So I am going to go to the Spark code now. So you can see that there is something called as app. Just expand this app and then click on Spark streaming.py. So this is the starting point for this code. Again, as usual, I'm going to read it as runtime argument. So if you can click on run, edit configurations, click on Spark streaming, you can see that I'm passing dev as an environment variable. Runtime argument. Again, we have this log4j, creating the Spark session, creating the configuration file, all such usual things that we're already aware of. So this portion, right? So all these variables that I've mentioned here, I'm trying to read it from this configuration file. So that's what this portion is talking about. So once we read all the details from this configuration file, so then we are going to create the topic. We are going to create the topic from the topic name. Let's say I wanted to read the data from a test topic because that is the topic where we are trying to push all the data into, right? Test topic. And then we have this function called as read from Kafka stream. So you can see that what are the things that we're passing: Spark session and logger, then Bootstrap servers, and what is the topic name from which we are going to push the data into, and what is the offsets. So just click on it. Spark session dot read stream dot format is Kafka, and we have to mention the Bootstrap servers. And subscribe is nothing but from which topic we wanted to read the data from, and starting offsets. So starting offsets can have values as either earliest or latest. So starting offset is nothing but this. So we are going to read all the latest data, right? So that's how we should be able to create a Spark streaming data frame, right? And once you create the streaming data frame out of this, you have this transaction detail filled up with your streaming data. That is nothing but your streaming data. Now let's do one thing. So let's take a step-by-step approach. So once you read the data, and then let's see how the data is being presented. So let's go to this stream transformation. Okay, we are doing a lot of things here. So before coming here, let's do one thing. Let's try to go here, and you can see that stream transformation started. And generally, whenever you get the data from a Kafka topic, it will be like, binary form, right? So we are going to typecast it to the string type. So let's do one thing. I'm just thinking if I can comment out this portion. Just a minute. So I want to take a step-by-step approach. Hence, what I would like to do is, whatever data from that I get, I wanted to just print the schema of it, right? So that's what my main goal is. And for now, let me also comment out this portion. I'll tell you why I'm commenting this little later. Guys, this is a very complex project, so it will take time to understand. So don't worry about it. So you have to go through this recording multiple times to understand it better, right? You have to go through this recording, you have to practice the way I'm showing it, right? So it will take time. Remember, this is not a simple project, this is a complex project. This is how it will be in the project, right? So in the project, code base will be something like this. So it will take some time. So, right? So don't worry about it. So you have to go through the recording multiple times, practice this project multiple times, only then you'll get a hang of it. Right? There is one question which I got in the chat. In real time, we need to write all the code, or is there an existing code so that we can do modification of code? Yeah, so again, one good thing is, you don't need to write code from the scratch. So most of the code will already be there. You have to understand the code, you have to understand the flow. There may be some bugs you have to fix, there might be some features that you have to add, but good part is a lot of code must already be there. You don't need to develop anything from the scratch. So don't worry about on that part. So now I'm going to basically run this streaming job. Right click on it, say run. Let's see how it goes. So see here, whatever data that we get from Kafka is actually be in this form, right? So you'll get these fields. You have key, which is in binary form. You have value, which is again in binary form. On the topic name from which we are going to read the data from, and what is the partition number, and what is the offset ID, and timestamp type, and then timestamp, right? So these are the fields that we will definitely get when you read the data from Kafka topic. And remember, this is a binary form, right? We are interested in the value column, but it is in the binary form. So we have to typecast it or change it to the string type so that we can process our data. So I'm going to take only two fields out of this value field, which is in binary form. I'm going to typecast it to string form, and timestamp type I'm going to pick it up. So these are the two fields that I'm going to take, right? So let me go to this portion now, stream transformation. So now we are clear with the schema of the data that we're going to get, right? So what I'm going to do is I'm going to basically going to get only those two fields, right? What am I going to get? I'm going to get only the value type and a value field, and I'm going to convert it to the string type. And then also I'm defining the schema for this. So what is this transaction detail schema? Let's click on it. Okay, transaction details schema, must be somewhere here. Let me go to my utilities folder. Yeah, here is my schema. You remember the schema, right? So this is how we define the schema. Struct type dot add transaction ID, transaction card type, transaction amount, transaction date type. So this is how we're going to define the schema. And this schema we are going to apply it here. So from JSON, that's a JSON data that we get. From JSON is nothing but from JSON is actually going to take two things as input. One is nothing but the column name. Second one is nothing but the schema, right? So it's going to check whether the given data that we have is compatible with the schema that we have. And we are trying to give an alias to that by saying transaction detail. And we are selecting the timestamp column. Only two things we are selecting, value column and then timestamp column. So let's go back to the streaming job. Where is the streaming job? Spark streaming. So I'm going to run this again. I just want to show you the schema that we get when you do it. So we are going to get two things now. One is nothing but your transaction detail is the alias that I gave, which should be of string type. So transaction detail, which is of struct type, and then timestamp column. And also I have told you in one of the previous sessions, right? So if you wanted to get all these columns, transaction ID, transaction card type, and everything, if it is of struct type, what we can do is we could apply dot star operator so that we'll get all these columns into the same level. So that's what I'm going to do now. I'm going to apply dot star operator on this struct type, that is transaction detail, to get all the individual columns. So here you can see that I'm going to apply dot star operator. So I'm going to apply transaction detail dot star so that I'll get all those columns. And then as usual, I'm going to select the timestamp column. So let me just return this data frame. So I'm going to print this schema and I'm going to return it, right? So now all the columns will be at the same level. Let me just run this code again. So have a look here. We're able to get all the columns: transaction ID, transaction card type, amount, date, time. Everything is at the same level right now because we applied dot star operator on struct type. Now what next? So now I'll talk about the actual problem statement. So the actual problem statement goes this way, right? So we need to find out the total transaction amount by grouping the transaction card type. So it's very clear that I have to group it based on transaction card type column. And then we have to perform an aggregate operation called as sum on top of transaction amount column, right? So that's what I'm trying to do here. I'm trying to group it based on transaction card type. I'm trying to perform an aggregate operation called as sum on top of transaction amount. So, and then finally, what I'm trying to do is I'm trying to select transaction card type and transaction amount. I'm giving an alias to it by saying total transaction amount, right? So let's see the schema of this. So these are, you have to take a step-by-step approach, right? If you try to understand, if you try to go through everything at a time, you may not be able to get it. So you have to take a step-by-step approach to understand anything. So let's go to the streaming job and then run it again. So have a look here. My final data frame will have only these two things: transaction card type and then total transaction amount. Only these two things will be there. Hey, just give me a minute. Hey guys, sorry for the interruption. I got some important call. So I had to pick it up. Yeah, now let's start pushing the data and we'll try to see the data being consumed. Right. So I'm going to uncomment this piece of code and I'm going to give that statement here. So we are going to get finally this data, right? So you're going to get the data something like this. So I'm going to return this data frame. So let's say df file. So you have seen the schema, right? We'll have only two columns. Now I am trying to change this data such that I can even push this data to Kafka topic. Hence, I'm trying to define a new column called as key column, and I'm trying to use lit function to have the same key for all the records. Then I'm trying to specify the transaction card type and transaction amount. So I'm going to print the schema of it. So and then once you get the data frame, here, so stream transformation, we're going to get this transform df, and I'm going to write this transform df. You can see that I'm going to write this transform df to multiple sinks or multiple destination. I'm going to write it to the console sync. If you can click on console sync writer, you can see that we're going to write the same transform data by using write stream. Processing time is one minute of time. On output mode, whatever output mode that I've selected, truncate equal to false will show the full data for you. And checkpoint location is also very important because let's say you try to run your Spark job and the Spark job fails. And when you rerun the Spark job, it should automatically resume wherever it left off, right? So that's where this checkpoint location comes into the picture. And then finally, we are mentioning the format as console. So this will write the data to the console sync. And apart from that, it will also write the data to the Kafka topic. Let's go to write to Kafka stream. So here we are again mentioning the transform df here, transactional detail df. Let's go and check that. Transaction detail df. Where is that? Transaction detail df. Just a minute. So transaction detail df. We are going to take that, and then I think this should be transform df. Let me just modify this and then see. Transform df, bootstrap servers, output topic, processing time, all such things that we're giving here. And we are going to select the key and the value. So we are going to typecast it to string type, and then we are specifying write stream as format as Kafka, bootstrap servers, topic name, output mode, checkpoint location. So we are going to write it to console sync and Kafka sync also. And in fact, we are also going to write it to the file sync as well. So if I can click on file sync transformation, and we are going to again write it to the file also. So you can see that we're going to write it to the files as well. Transaction detail dot, and then we are selecting all the columns that we want, and we are getting this data frame. And then finally, we are going to write it. Right, so I'm going to write it in the Parquet format. So let's do one thing. Let's try to run this code and then see. So let's run this entire code. First, let's start the streaming job. So now I'm going to go and modify my, so the streaming job is running continuously, right? So I'll leave it as it is. So I would like to go to my scripts here. So I would like to push the data to the test topic. So I'll go to this create input topic, and I would like to change the topic name to a test topic. So I have Zookeeper running, I have Kafka running. So I'm going to run the script so that it creates a topic for me. It creates a topic for me with the name called as test topic. Test topic has been created. Now when I run my producer, it will start producing the data to that particular topic. Right? But before that, let's also check this. So we are going to read the data from output topic, because finally we are going to push the data from Spark Job to the output topic. So let's start the producer now. So I'm going to start the producer with, let's say, 5 records first. Something is wrong, just a minute. File not found exception. Okay, you can see that, we can see the data is coming in. Transaction card type is master. You can see the transaction amount and what is the transaction card type, etc. Right. So we are also pushing the data to multiple topics, so multiple destinations. So we should be able to see the same data flowing here as well. Let me see. I think there is something wrong. There is something wrong with this console checkpoint directory. Anyways, let me stop this again and I'm going to rerun it again. I'm going to remove the checkpoint directories, because if you rerun it again, so your Spark job may fail. For now, I'm going to remove the checkpoint directories that is getting created. I'm also going to stop this consumer and let me start it again. Let me close this. So I'm going to change the number of messages to be 100 now. Let's start the streaming job first. Then I will start my producer. So I have to also start my consumer. So consumer is not running. I think let me run the consumer also. So have a look here, guys. So Python producer is pushing the data to the test topic. Spark structure streaming is reading the data continuously. It is pushing the data to the sync as one of the console sync is one of the sync. Also, it is pushing the data to Kafka topic. We are able to read the data from Kafka topic also. And also we are pushing the data to the sync file sync as well. That is, we are going to push the data to the files also. So if you can go here, So somewhere here I should be seeing my data. So I hope you're getting the idea, right? So let me go and check my writers. So file sync writer. So you can also see the location, output location. Just go to output location. Output location is nothing but a variable, right? So I can actually go to the constants or application or properties file to figure out the exact location. Output dot file dot path is nothing but output. So you should have something called as output folder created here. Let's see if that is available or not. Yes, you can see output folder is here, and you can see that it's writing the data in the Parquet format. These are all CRC files. If you scroll down, these are all your Parquet files, right? So I hope you're getting the idea, right? So we are continuously pushing the data based on the producer, and it produces some message and it's continuously read by the Spark structure streaming of. It return the data to console sync as well as Kafka topics as well as to the file sync, that is these files. So this is very, very close to the industry grade project, right? 95% matched, right? So this is how we are going to work in the projects, right? Also, there is one more interesting use case that I have developed in the recently in this project called as data mover. So what we'll try to do is we will try to move all the output records or the process data from one location to other location. So let's go to this location. So I'll go to this location. So I'll go to downloads folder. So I have this Kafka stream integration, and if I can go to output folder, so this is where my all of the files are, right? So now what I will try to do is I'll try to move all these files into a different location. So I'll go to my C drive data folder. So I'm just going to remove if the folder already exists. So now what this will try to do is this will try to take a location as an input, and it's going to move all those files into a different location. So let me just run this. So before running it, you can see that downloads folders, Kafka stream integration and output. This is where all of my process data is available. And I wanted to move all this from one location to other location, right? From this location to C drive data folder, process data later should be created. Let's run this. Now this must have moved everything. You can see that it is moving. It's moving everything, right? Now let's go to C drive data folder. You can see process data latest created. Right, you can see that all the data is available here. Right, so this is how we are going to work in the project, guys. So we're continuously reading the data from a topic, and we're continuously processing that data. We're pushing the data to Kafka sync, console sync, and file sync. And along with that, for each of the sync, we are maintaining the separate checkpoint directory as well. So if I can show that in the project structure, if you can scroll above, you can see that a checkpoint directory is created for each and every sync. You can expand this. For file sync, you have file checkpoint directory. For Kafka, you have Kafka checkpoint directory. For console, you have Kafka console checkpoint directory. If you can expand this, you have different commits folder, offsets and sources, etc. So there is one question in the chat. So how to read the output data file? So just mention that path. So what is the path? Path is your output folder, and mention the format as Parquet, and you should be able to read it. Anyways, you don't need to worry about it, because anyways we are pushing the same data to console sync, and we're pushing the same data to Kafka sync. If you still wanted to read the same data, just mention the format as Parquet format and read it as a data frame, right? So that's how we are going to work in the projects, guys. So very, very close to this project. I mean, industry grade projects are very close to this project, right? So I will share this entire code with you, but one request is, don't share this code with anybody, because this has been developed with a lot of effort, right? So don't share this with anybody, right? I think pretty much this is what I wanted to cover, guys. So any questions anybody have, let me know. I'll wait for a couple of minutes. Any questions so far? Okay, if there are no questions, I think we're good. So I'm going to cover one more project tomorrow at the same time, but there is one prerequisite. So you have to understand some AWS concepts. So that's where, I wanted to take a session. Actually, I was supposed to take this yesterday, but because of some reasons, I could not take it. But today I'm going to definitely take it. So it will be at, I'll tell you the exact timings. So we are left with finally 2 sessions in our training. One is on AWS, one is on project on AWS with PySpark combination. So I'll tell you the timings when we are going to meet next again. So tomorrow at the same time, we'll have one more project session. But before that, I'm going to take a AWS session. That will be at 11 a.m. CST or 12 p.m. EST. Right? We are going to meet again. So tomorrow we'll have 2 sessions. One is in the morning, one is in the evening. Right? So if you miss this AWS session, don't worry, you're going to get a recording. But I would highly encourage you to not to miss this project session. That will be a combination of AWS and PySpark. Okay, 2 sessions will have 11 a.m. CST or 12 p.m. EST or and 9:30 p.m. CST. So these are the 2 sessions that we are going to have. That will be the last session. So totally we are left with only 2 sessions for now. Okay. Any other questions, guys? Anybody have any other question?
Hi, Vamsi.
Go ahead, Sunanda.
I want permission to access the file that you have given yesterday.
Okay, I'll give you access now. You can
Yeah,
just.
I'm waiting. Thank you.
Okay. Okay, guys. Let's meet at 11 a.m. CST or 12 p.m. EST. Then we'll talk about AWS. See you then. Bye.
Bye.